Next, we'll move on to another concept of function, which is recursion. Now, if you're coming from other programming languages, you might know that recursion is something which people do recommend to use and people also recommend to don't use, because a lot of time recursions is not quite safe, but at some places it is efficient, at some places it is not efficient, at some places it will give you the correct solution which you want, and at some places it won't. So yeah, you need to be brave enough to play with recursion. So what is basically recursion? Recursion is the process of defining something in terms of itself. So in recursion, what we do is we suppose we have a function. So what a recursive function will do, a function will call itself. Over here, you can see in this example, this factorial function, we have called factorial function inside the factorial function, but passing some different values. Because if we pass the same value, we might fall under an infinite recursion, which we'll shortly see what it is. So in Python, we know that a function can call other functions, but it is even possible for the function to call itself. So these type of constructs are termed as recursive functions. Let us look at the logic of this particular function, that is the factorial function. Now we all know what factorials are. So when I talk about n factorial, so n factorial is n into n minus 1 factorial. And n minus 1 factorial in turn is going to be n minus 1 into n minus 1 factorial. So instead of having loops where I decrement the value of n, we can simply call this function again, but pass a value which is one less than the original value. So when I say I want to find the factorial of say 10, what I do is 10 into factorial of 10 minus 1, that is 9. So this is basically the logic which I want to use. But if I go simply calling this function, I will fall under infinite recursion, which will be demonstrated over here. So yeah, we'll have a look at it shortly. So, so we want to get rid of that infinite recursion and that hell thing. So what we do is we mention a base case over here. So what is the base case? We know that the factorial of 1 is 1. So whenever we encounter a 1, what we do is we return 1 because we know that when x is equal to 1, the factorial of 1 is going to be 1. So we simply return that value. We don't call the function itself. So this is what we do. This is what we call the base case. So let me mention it in the comments as well. So this is the base case. Let's move on. Next, we have the else statement where what I do is return x into factorial of x minus 1. So we'll take this example first. So when I have number equal to 3, so what it will do over here, I've called this factorial and then the number. So number will take the value 3, which will go over here. Now look at this, what actually happens in each iteration. So first of all, if x is equal to 1, no, x is equal to 3, so this is false. So we move on to the else block. Now what we do is return x into factorial of x minus 1. Now this statement wants to return something, but it won't until unless I compute what is the value of this particular call. So what this does is 3 into factorial of 3 minus 1. What is 3 minus 1? 3 minus 1 is 2. So now we have a call to factorial, but with a value of x as 2. So now this goes under this function. If x is equal to 1, no, the value of x is 2 and not 1. So we move to the towards the else block. Now else block again wants to return something, but it won't until I compute this value. So what it does is x into factorial of x minus 1. So over here the value of x is 2. So what it does is 2 into factorial of 2 minus 1. The value of 2 minus 1 is 1. So this is what I get, 3 into 2 into factorial of 1. Now again we call this, but the value of x this time is 1. So this goes inside this function. Now as you can see, the first condition over here is true because indeed x is equal to 1. That is what we have passed the value in our previous iteration. So what we do is return 1. So once we return 1, factorial 1, we now know that the value of factorial 1 is 1. So in our previous call, we had 2 into factorial of 2 minus 1, that is 2 into factorial of 1. Now we know that the factorial of 1 is 1, so we replace that. So in our previous call, we had 2 into 1. Now the value of 2 into 1 is obviously 2, so we will return 2 to its previous call. So in its previous call, we had 3 into factorial of 2. Now we know that the value of factorial of 2 is indeed 2. So what we have is 3 into 2. 3 into 2 is 6, and this is the value which we finally return over here in this call. So this is what I get. So the answer is 6, and this is what I get as the output. To better understand this pictorially, here is one nice demonstration of what actually happens when x is factorial of 3. This 3 goes inside this function. So if n is equal to 1, no, we go to the else block. So n, which is 3 over here, into factorial of n minus 1. That is factorial of 3 minus 1. That is factorial of 2. This is another call. So this again calls another function that is the factorial, but the value of n this time is 2. Then the first condition is false because n is 2 and not 1. This goes to the else block. Return n, that is 2, into factorial of n minus 1, that is 2 minus 1, that is 1. So this is another call, factorial of 1. So this is another such function. So factorial, over here the value of n is 1. So n is indeed equal to 1. So I return 1. So this return value goes into its previous call, which is this call. So over here what I get is factorial of n minus 1, which is this call. Since I've returned 1, so this whole thing will take this value 1, that is 1 is returned. So 2 into 1, the value is 2. So 2 is returned to its previous call, that is over here. This is 3, this is 2. 3 into 2 is 6, and that is what is returned into the initial call which we had done. So factorial of 3 is the answer for this is going to be 6, and that is what gets stored in this variable x. So this is how recursion works. I know that was quite confusing, but practice will make it much easier for you. Now this is what I was talking about, infinite recursion. Over here I don't have any such base case here. So each time when we get into this function, we again call the recursive function. So in the next call, when I go into the recursive function, it will again call the recursive function, and this goes on and on and on until your Python says, "Bhai main thak gaya." In that particular case, what happens is this produces an error. This is the recursion error. So when you fall in the infinite recursion tree, so this is the error which you get. Now, advantages of recursion, as we were saying, recursive functions make the code look clean and elegant. This was looking exactly what we wanted to do, just like we have seen in the factorial function. As I said, n factorial is n into n minus 1 factorial. So instead of using a loop, we could actually call the factorial function once again to compute the factorial of n minus 1. So this will actually make it look like exactly the logic what it was. So it makes the code look clean and elegant. A complex task can be broken down into simpler subproblem using recursion. That is what we do. Now, if we wanted to compute the factorial of 3, we first moved on to 2, then we moved on to 1. We know the value of factorial 1, so that gets returned to the previous recursive call. So what basically we are doing is we are taking some complex we are taking a complex problem and breaking down into simpler and simpler codes. Similarly, we could have factorial of 100. So now that would sort of become difficult, but recursion will make it look easier. Sequence generation is easier with recursion than using some nested iteration. So yeah, at some particular point, the sequence generation is much better in recursion as compared to iterations. Disadvantages of recursion: sometimes the logic behind recursion is hard to follow through because recursion goes into depth and depth and depth. So each time around we get a recursive call. So sometimes it is hard to find out what might be the logic which gets implemented in, for example, the 50th recursive call. Because over here I had the simple example of this factorial thing, but I might have some complex function also. So in those cases, it might be difficult to guess the logic which might be there in a particular recursive call. Also, recursive calls are expensive as they take up a lot of memory and time. Now, each recursive call basically takes up some value in your memory, basically takes up some, you know, uh, some place in your memory in the form of stacks. Now, I don't know if you know what stacks are, but that are basically the data structures which we have. So stack is also one sort of place in the memory where you store these objects like dictionaries and other objects as well. So these are kind of expensive and they take up a lot of memory and time. So when you're looping, you're not taking an additional space for a function as such, but when you're using recursion, you're calling a function again and again. So that takes up some space in the memory and eventually it takes up some time as well. So this is another disadvantage of recursion. Then recursive functions are hard to debug, as I mentioned. Sometimes it is kind of difficult to guess what might be happening in some particular recursive call. So yeah, this is another such disadvantages of using recursion.